Good morning, alien enthusiasts, and welcome to another Angry Alien Bulletin. I am finally here back in the United States, in Orlando currently, going to be heading to Titusville tonight to cover the fueling of Artemis II as part of the wet dress rehearsal. Some of that stuff is actually underway, and given the last video that I released on the topic, the new environment, a new culture that might be in place over at NASA, I'm really starting to feel that way, because a lot of what was necessary in the wet dress rehearsal, aside from fueling up, was taken care of over the last couple of days, leaving just pretty much the stuff that couldn't be done in cold weather. Again, that's impressive that NASA has been doing this much ahead of the fueling process in order to make sure that they are successful once they get to that point, or that nothing is going to trip them up. Really focusing, I think, on trying to get this rocket off the ground in February, which, again, that suggests to me a sense of urgency and a new culture that's in place at NASA. All that having been said, though, really appreciate your support in getting me and my producer here. Thank you so much. Looking forward to bringing you some great coverage soon. But in the meantime, things continue to happen with 3I Atlas, and finally, a remarkable discovery. James Webb Space Telescope was able to image the nucleus in sufficient detail to where we can now estimate the size of the object. And even though it's not as huge as some of the upper range estimates that Avi Loeb was talking about after its discovery, it's much, much bigger than most astronomers were saying about a month ago. And there are very good reasons why these astronomers thought it was small, and it really isn't. And the fact that it is as big as it is, that means significant things for other observations that we have made of 3I Atlas, or rather, it's created circumstances that are difficult to explain. And that's not the only thing. It's not just about the size of the nucleus. New discoveries were made in terms of composition, including a new element that simply shouldn't be there. All right, folks, so topic number one, we need to talk about the size of the nucleus, how this size was estimated, the observations that James Webb made, and later on in the video, we're going to find out why the fact that 3I Atlas is as big as it is, why this is important, why this makes some of the other things that it did, most substantially the non-gravitational acceleration, its change in speed and trajectory when it reached perihelion, why all of that gets really strange, given the fact that we now know how big this object truly is. So, as I mentioned before, the Hubble Space Telescope report includes a successful detection of the nucleus of 3I Atlas based on post-perihelion data from December 2025 to January of 2026. The nucleus is inferred based on these observations to have a diameter of 2.6 kilometers plus or minus 0.4 kilometers, so it might be as big as 3 kilometers or as small as 2.2. And since mass scales as diameter cubed, that means that 3I Atlas is about 40 times more massive than 2I Borisov. And more importantly, as of December 2025, most astronomers were saying that 3I Atlas was about 1 kilometer in diameter, and these new observations show that it is 27 times more massive than those recent estimates. And because it is a lot more massive, that has some significant ramifications on other observations that we have seen with this object. But let's go ahead and continue with the discovery. Compared to the pre-perihelion brightening trend, 3I Atlas faded more rapidly after its closest approach to the Sun on October 29, 2025. This activity asymmetry is further corroborated by a post-perihelion surface brightness profile that is significantly shallower than its pre-perihelion counterpart, meaning that it calmed down quite a bit after the close approach with the sun. The nucleus light curve exhibits evidence of temporal variation, and this could be attributed to rotation modulation. In other words, the pulsing that I've talked about in previous episodes, we still have that pulsing taking place that might have something to do with rotation, but then again, based on the pre-perihelion rotation rate, may not really be the case because it was pulsing much faster than it was rotating before it achieved perihelion. Incidentally, this nucleus size estimate was published in a peer-reviewed paper entitled Nucleus and Post-Perihelion Activity of Interstellar Object 3I Atlas Observed by Hubble Space Telescope. This was published by Manto Hui, David Jewett, Max Muchler, Jessica Agarwal, and Young Kim. All are very respected astronomers from all over the world, and they are the ones who came up with this overall size estimate, which once again clashes considerably with other estimates made by other astronomers in previous months. And in a minute, you're going to find out why this difference makes explaining some of 3I Atlas's behavior a lot more difficult. All right, so now we know how big 3I Atlas is. It's a very important discovery, and I'm really happy that we figured all of that out before it made its way out of the solar system. Later on, as I said before, we're going to find out why 3I Atlas being this big is significant and why it makes its behavior a lot more difficult to explain. But we need to talk about the composition as well. 3I Atlas, after perihelion, after reaching its close approach with the sun, has been producing material, producing elements that it wasn't doing before. And this includes a brand new element that shouldn't be there. So the new Webb telescope paper presents the first spectroscopic characterization of 3I Atlas after perihelion, at least the first spectroscopic analysis carried out by James Webb. Again, keep in mind, James Webb is an infrared telescope, meaning that it can pick up a lot more information about the various elements, the composition of a coma or an object or even a planet than other telescopes can. When the object was at heliocentric distances of 2.2 and 2.54 astronomical units respectively, that's when James Webb took its observations. First of all, H2O started showing up a lot more than it did before, whereas carbon dioxide dropped off a little bit. This is in sharp contrast to what was happening with this object pre-perihelion, where there was lots and lots of carbon dioxide and very, very little water. However, nickel is still there in vast quantities. And again, this continues to be a very strange thing indeed. Although iron is showing up now, it wasn't showing up before. And if you look at the ratio of nickel to iron, this is well outside of every solar system comet in terms of the ratios of nickel to iron. And again, the only examples that we have of nickel showing up in these kinds of quantities that we have ever observed is coming about as the result of industrial processes and not the result of any sort of natural process, although there are natural theories that could bring all of this about. It's not impossible for natural processes to make this happen. We've just never seen it before. But here's the big issue. Methane is suddenly showing up, and quite a lot of it. And this should not be happening because methane is an extremely reactive and dynamic substance. This is the sort of thing that should have been showing up from 3I Atlas from the very beginning, much more so than carbon dioxide, water, or anything else. Methane should have been apparent in spectroscopic analyses of this object from the very beginning, and yet it didn't. The production rates of methane molecules in the two observing epochs are 13.7 and 27% of the water molecular production rate, respectively. In other words, more methane started showing up, the further away the object got from the sun. This again makes no sense. An element as dynamic as methane should have been showing up in vast quantities, especially close to the sun, and then should have quieted down a bit as it got further and further from the sun. Instead, what we are seeing is the reverse. But what is so incredibly bizarre is the fact that methane didn't show up at all. It is a hyper volatile. In other words, it has a much lower sublimation temperature than even carbon dioxide. So when we saw all of that CO2 as 3I Atlas was approaching the sun, the methane should have been there, and it should have been there in vast quantities, and yet we saw no methane at all. Now, one possible natural explanation is that methane was depleted in the outermost layers of 3I Atlas, but still buried deep inside the nucleus was more methane that eventually got exposed as more and more of 3I Atlas sublimated away. But in this scenario, the early detection of carbon monoxide should not have happened because carbon monoxide is more volatile than methane. Therefore, the carbon monoxide should have been gone as well, along with the methane in the outer layers of 3I Atlas. But this didn't happen. Instead, we had carbon dioxide, carbon monoxide, and a little bit of water in early detections. Now, lots of water, still carbon monoxide being present, and then all of a sudden, all of this methane. Currently, there are no natural explanations for this phenomenon. All right, so we've got the size of 3I Atlas, we've got the weird composition of 3I Atlas, but now we need to examine why 3I Atlas's size matters. The fact that it is so much bigger than most astronomers were estimating when it comes to non-gravitational acceleration, when it comes to the fact that it changed course and speed, direction, etc., at the time of perihelion. The fact that it's also this big makes that change, of course, very difficult to explain. Okay, in this part of the video, I'm going to be quoting from a paper entitled The Size of 3I Atlas from Non-Gravitational Acceleration by John Forbes and Harvey Butler at the University of Canterbury, Christchurch, New Zealand. Quote, the third macroscopic interstellar object detected in the solar system recently passed through perihelion with the best fitting models of its trajectory now featuring non-gravitational acceleration. We assess how much mass loss is required to produce plausible non-gravitational acceleration solutions and compare with estimates of the mass loss. We find that they are consistent when the nucleus of 3I Atlas is around 1 kilometer in diameter. For a recent solution with a time lag in the acceleration, we find diameters between 820 meters and 1,050 meters. In other words, 1/27th the mass of what 3I Atlas actually weighs is a size consistent with the observed non-gravitational acceleration. Now, we always knew that 3I Atlas shifted considerably off of its previous trajectory, and a lot of that shift could be explained with gravitational effects. In other words, the effect of the sun as 3I Atlas made its close approach with the sun. However, the rest of it had to be the result of non-gravitational acceleration. In other words, explosive outgassing or a rocket effect from the nucleus. And in order to get the rather substantial amount of non-gravitational acceleration that was observed, these astronomers estimate that a size of 1 kilometer or less is necessary. In other words, something that's 27 times as heavy is going to be a lot more difficult to shift that much with natural outgassing. And this is something that we've been talking about quite a lot on this channel, is the fact that the observed shift with 3I Atlas, although consistent with NGA that we've seen from natural comets should only be coming about if the object is relatively light. An object that's nearly 3 kilometers in diameter should not have been able to shift that far with conventional outgassing. Now, with especially explosive outgassing, or perhaps a much larger surface area exposed to the sun than we thought, something along those lines, then perhaps this still could have happened naturally, but nevertheless, it is a strange anomaly, and just one more anomaly to add onto this bizarre object. So 3I Atlas continues to throw curveballs at us as it makes its way out of the solar system. As I said before earlier on in the video, all of this is very difficult to explain when it comes to the interstellar objects we've observed thus far. This thing is so much bigger than a Oumuamua or 2I Borisov, the only other confirmed interstellar objects that we have ever seen in our solar system. And again, it doesn't make a lot of sense. If we're seeing something as huge as 3I Atlas, and granted, it doesn't sound like 3 kilometers or 2.5 kilometers is much bigger than 1 kilometer, but as we saw in the video, it really is. It's much bigger than any object we've seen so far. If we're seeing something this big, why did we not observe dozens of Oumuamua-size objects? Dozens of 2I Borisov comets? It doesn't seem very likely to be seeing something this big and yet such an absence of smaller objects at the same time. On top of all the other strange anomalies with this object, I think we have a lot to learn about 3I Atlas even after it leaves the solar system and we can no longer see it. But fortunately, very glad that NASA took this seriously enough to point James Webb at it again after perihelion. They thought it was important enough to check it out, and the fact that they did means that we've learned so much more about this mysterious object. And as the data is examined in greater detail over the months and years to come, I think there's a lot more that we're going to learn about this mystery. And I think as time goes on, we're also going to learn that this thing wasn't a comet. At least not a comet as we understand comets, but something very, very different. Maybe not artificial, but unique in its own way. And I think as we observe more interstellar objects in the years to come, that is going to be confirmed. 3I Atlas is going to stand apart from everything else we see passing through our solar system. Thank you very much for watching. Please don't forget to like and subscribe. Thank you so much again for your support in getting us out here to Cape Canaveral. Looking forward to bringing you some fantastic content in the days ahead. Thanks again, and until next time, stay angry about space.